This is Daniel Coosbury, and in this video, we're going to look at the normal distribution. So I've already made a video on the standard normal. This video is going to kind of elaborate more on the normal distribution as a whole and show you how the standard normal is related. So I'm going to go ahead and get started. The normal distribution is a bell-shaped distribution with mean mu and standard deviation sigma. The standard normal distribution is a special case of the normal where mu is equal to 0 and sigma is equal to 1. So this is something I've already shown in a different video. I've done some work with it. The normal distribution is more general than the standard normal in that what you need to do in order to define it is just specify the mean and specify the standard deviation. And you've got a nice bell-shaped distribution. So this has actually come across your path at some point probably before because the empirical rule applies to normally distributed data, which the empirical rule is this one down here, which shows if you go within 1 or 2 or 3 standard deviations of the mean, you've captured these percents of the data. This is a good picture of what a normal distribution would look like. You would specify your mean, so it can be any number, really. It could be a negative number, a positive number, it could be huge, or it could be 0. And then your standard deviation would decide how spread out your data is. So it's a difference between a normal distribution that looks like this and a normal distribution that looks like that. They can both be normal because they have a mean and one spread out more than the other based on its standard deviation. But I'm going to show you how the normal distribution is related to the standard normal and how that's going to help us do some problems with the normal distribution. So here, just some notation. If we want to identify something as being normally distributed, we need to specify what the mean and the standard deviation are. So we can know a lot of things about a random variable just by saying it's normal, just by saying its mean is some number mu, and its standard deviation is some number sigma. So for example, if a random variable had, I don't know, the mean 3 and the standard deviation of like 2, then we could write it like this. 3, 2, where this is the mean and that's the standard deviation. Or you could say that mu equals 3 and sigma equals 2. So those are parameters, and we would specify what those are. So based on that then, this is a nice little result. If you have a normally distributed random variable with the mean mu and standard deviation sigma, if you subtract the mean and divide by the standard deviation, you get this guy, which we've already met. His name is Z. He comes from taking something normally distributed, subtracting the mean, and dividing by the standard deviation. So that's Z. So if you have something that's normal already with the mean, mu, and standard deviation sigma, you subtract mu, divide by sigma, and you have something that's standard normal that we can call Z because it's standard normal. So what that means is we can convert from any normal distribution to a standard normal distribution simply by subtracting the mean and dividing by sigma. And that's how we're going to end up doing probabilities. So this says the same thing that was on the last slide, a little bit of repeat, but the classical way of computing probabilities using a normal distribution involves converting to a standard normal distribution first. So we can take any sort of data value from a normally distributed thing, subtract mu, divide by sigma, and get something that's standard normal. And specifically, if x is a data value, it's a little x, just some value that we pull out, then we can introduce some idea called a z-score. So if x is a value, we can convert it to a value we'll call z by subtracting the mean and dividing by the standard deviation. So at this point, I've said subtract the mean and divide by the standard deviation about 10 times. That's the method we're going to use to go from normal to standard normal. So this is standard normal. Why is that important that we go to standard normal? Well, because when we did probabilities in the standard normal video, we found that there's a nice table that people use to find probabilities, but you've got to have something standard normal first. This is powerful because if you start out with any normal distribution, with any mean and any standard deviation, you can get to the standard normal distribution by finding a z-score, and then we can use that to find probabilities. And that's what I'm going to spend the rest of the video showing you. So I'm going to do 5 problems similar to the one in the standard normal video. The difference is now I've got something different. This is interesting. I thought it was funny. Suppose the chest size of 19th century Scottish militiamen are normally distributed with a mean of 39.83 inches and a standard deviation of 2.05 inches. So I've got something that's normal with a mean of 39. I'm just going to kind of jot it down a different way. This isn't writing well today. 39.85, and the standard deviation is 2.05. So that's kind of how I'd write it. And we want to find what proportion of militiamen have chest sizes less than 35. So what's going on our normal distribution now is our mean, this high middle part, is actually 39.85. And I want to find the probability that, or the proportion, we'll use the same method for probabilities and proportions, that I randomly select, or the proportion of militiamen that have chest sizes less than 35. So on my number line, 35 could go right here because it's less than 39. And I want to find the proportion of people who are less than 35 in their chest size. Again, I think it's funny that we're talking about people's chest sizes. But anyway, so we want to find the area of that region. This is a probability density curve, which means the area under the curve is equal to 1. So this area is a probability. It's some number between 0 and 1. And we want to find the probability that, I'm going to write it like this, that x is less than 35, where x is going to be my normally distributed thing with mean 39.85 and standard deviation 2.05. Now, I don't have a chart for this distribution, but I do have a chart that works if the mean is 0 and the standard deviation is 1. So what I'm going to do now is I'm going to get my z-score for this value 35. So we're going to treat this 35 like my little x. Let me write that in a different color. So this is my little x. I'm going to treat this 35 like my little x, and I'm going to do a z-score. So the z-score is you take your x value, you subtract the mean, and you divide by the standard deviation. Let me do that on the calculator real quick. So I would do this on the calculator by taking 35 minus 39.85, there's that, and then divide by the standard deviation, which is 2.05. And I get negative 2.37. I'll round it to 2 decimals, 2.37. Negative 2.37. That's my z-score. So what this means is where 35 lands on this distribution, it's going to correspond with negative 2.37 on a standard normal distribution. So if you allow me to draw that real quick, what I mean is if this is a standard normal where the mean is 0 and you go up to 1, 2, 3, negative 3, negative 2, negative 1, then this proportion here, whatever this probability is, we'll call it probability or whatever, is going to be exactly equal to the number I get when I find the area less than negative 2.37, which is this value right here. It's going to be this area right here. So I'm saying this and that are the exact same thing. You may find that hard to believe, but this is how the probability theory works out. The z-score comes from subtracting the mean and dividing by the standard deviation. And once you do that, you're in standard normal land now. And we'll find this probability the same way we found all the other standard normal things. So I'll go to my table A2, find the area less than negative 2.37, and I'm golden. So let me go to the table now. This is my table A2, where I'm looking for areas less than certain values. I need to go to the ones where z is negative. So there I am. And I need to find negative 2.37, I think. Yes, negative 2.37, which I'll start at negative 2.3 here, and I'll go out to the 7 column, negative 2.37. And I'll go down to right here, 0.0089. So I'm finding these probabilities the same way for this one, 0.0089. Oops, that's not my thing. So what I'm saying is the probability that x is less than 35 is also the probability that z is less than negative 2.37, which is, did I say 89? Yes, 89, which is this number right here. So this red probability and this blue probability are the exact same number. Ignore this little equal sign right there. So this and this are the same, which means this area is 0.0089. This area is also 0.0089. I've now drawn all over this slide. But my point is, the classical way of finding probabilities is by converting to standard normal first, then using the table. And when you do that, your answer ends up being the answer for this number before you convert it. So let me do a few other ones of those so you get the method straight. Same context, I've got X being normally distributed with the mean 39.83 and the standard deviation 2.05. I'm going to randomly select one militiaman and find the probability that its chest size is greater than 42. So let me put the mean back on here. I don't know what these other tick marks are. I could find out, but I don't want to. I want to find the probability that my chest size is now greater than 42. Okay, so just like in the last problem, I'm doing probability that X is greater than 42, but I need a z-score in order to use my table. I can't use my table until I get a z-score. So I'll do z is equal to 42 minus the mean over the standard deviation. I missed something there. So I got to get my z-score first before I can do anything else. So let's do 42 minus 39.83, enter, divided by 2.05. I got 1.06. We'll round to 2 decimals because that's what our chart does. It just goes to 2 decimals. So our z is equal to 1.06, positive 1.06. So this means that the probability that X is greater than 42 is the exact same thing as the probability that Z is greater than 1.06. And this is the number I can find on the table. I don't have a table for this, but I have a table for this. So now I can go to my table, find the probability that Z is greater than 1.06. Oh wait, I forgot something. Z is greater than 1.06 is going to be to the right of my Z value. I only have things to the left, so I've got to do one more thing before I use my table. I've got to rewrite this so I have a less than instead of a greater than. So this is going to be equal to 1 minus the probability that Z is less than 1.06. In other words, I'm going to find this area, this white area, and then subtract it from 1 to get the red area. So this is 1 minus whatever number I get from my table. So now I'm looking at the left, area to the left. Then I'll subtract it from 1. I know this is very complicated. You'll get used to it as you go. 1.06, 1.06. Let me find again. 1.06. So this number, 0.8854. 8554. Is that 8554? So you do the 1 minus thing, and you've got 0.1446. That's your answer. So this little sliver is 0.1446. That's the area. That's that red area right there. The white area is going to be 0.8554. So that's the same method. I start by taking this value, convert it to a z-score, and then use the table to find the probability. So once you convert to a z-score, you're at standard normal land, which means you can use the standard normal methods to find these probabilities. All right, let's do another one. I've got the exact same distribution, exact same situation. So this is 39.83. I want to find the probability that I have chest sizes between 37 and 40. I don't know where those lie on here. 40 is a little bit closer. 40 is actually really close to the mean. So 40 is like right there-ish. So I want to find this sliver. And you might not be surprised. The method I need to find this is the same with standard normal. I'm going to have to find all this area, and then I'm going to have to subtract it. Oops. What did I do? Then I have to subtract it from all of this area, this white area right here. So if I find this blue area first, and then the green area, I'll subtract the green from the blue, and I'll get this little sliver right here. That's the only way to do it with the table. So let's see. What I'm looking for, I'll call the probability that X is between 37 and 40. And Since I have two values here, I need to go ahead and find two z-scores. So let me go ahead and find my two z-scores. Z1 is going to be 37 minus the mean over the standard deviation. Z2 is going to be 40 minus the mean over the standard deviation. And I'll do both of these really quickly. Something's wrong. There we go. Sorry about that. I'm going to do 37 minus 39.83 divided by 2.05. So that number is negative 1.38. The other number is 40 minus 39.83 over 2.05. And that number is 0.08. Now I can round my z-scores to whatever I want, but I'm going to round it to 0.08 because my table only goes to two decimals anyway. So what this means is my probability that x is between 37 and 40 is the same as the probability that z is between negative 1.38 and 0.08. So this has now become a standard normal problem, like in the standard normal video, where I've got z between two values. The way we did it last time was we took the area to the left of the bigger value, which is z is less than 0.08. Yes, 0.08 is bigger than negative 1.38. This is negative, that's positive, so this is the bigger one. Then I'll subtract the probability that z is less than negative 1.38. So this is the area to the left of the smaller thing. So this is equivalent to this little white sliver. This is equivalent to the red plus the white. So we're finding the red plus the white, and then we're subtracting the white, so we end up with just the red. Now I'll go to my table, and I'll look for 0.08 on my table, which is, let's see, here's the 0.0, there's 8, so we're going to take 0.08, 0.5319. And now let's go find negative 1.38 on the table. Negative 1.3, I don't remember where the 8 column is. It's the one almost to the right. So negative 1.38, that's this one, 0.0838. I don't really want to do that subtraction in my head. So I'll do 0.5319 minus 0.0838.4481. That's my answer. So this red probability is 0.4481. The red plus the white is 0.5319, and the white is 0.0838. Now I know it doesn't look like it based on how I drew my picture, but I just kind of guessed when I drew my picture. The picture is going to help me make sure I have areas to the left to do these problems and so on. It's also going to help me pick the right part of the z-table, because if something's to the left of the mean or the right of the mean, I need to go to that right part of the table. The point with these problems is to show you that they work the exact same way as the standard normal problems do, but you've got to convert your values to z-scores before you can do the problems. And then they work just like the standard normal ones. So that's the big point of this whole video, is that if you can find standard normal probabilities, you can find normal probabilities using the table, but you've got to convert to z-scores first. Okay, let's do another one. I want to find the 80th percentile for chest sizes. So I'm going to start with my mean here. And I'm going to find the number, whatever that number is. That 3 never writes. That's going to be my P80. And I want to find the number that separates the lower 80% from the upper 20%. And we have a method when we're in standard normal land for how to do this. So the method in standard normal land is to go onto the table and find that what separates the lower 80% from the upper 20%, and that number is going to be our percentile. Now, I can go to my table and find this number. In fact, I'll go ahead and find it real quick. So I'm finding the number that's closest to 80%, which is going to be this number right here. So you see how 0.8 would be between these two, but this one's much closer. So let's use 0.84 as our 80th percentile. So 0.84 is the 80th percentile in standard normal land. But we're not in standard normal land. We're in this normal distribution where the mean is 39.83 and the standard deviation is 2.05. So I can't necessarily just say that's my answer, because this doesn't really mean anything when you're talking about chest sizes. Like, this isn't actually a chest size. It's just way too small. I've got to take this number and convert it to this particular normal distribution. So I've got to go from a normal 0, 1 to a normal 39.83 to 0.05. So now let's just think about how to do this for a second. I'm about to give you a formula that's going to get us there. But if we go from here to here by taking x and subtracting the mean and then dividing by the standard deviation, then to go the other way, we would have to do the opposite thing. So to go from here to here, we would have to use this formula. To go the other way, oops, I hit the wrong button again. To go the other way, I'm going to have to use a different formula, which I'm about to give you. So to go from normal to a special mean, think about doing the algebra. Multiply by sigma on both sides, add mu. You end up with this formula. Z, I think usually the mu's first. Mu plus sigma times z. This is the formula. So this formula will get me from standard normal to any other normal I want. I'll take the z-score, multiply it by the standard deviation, and add the mean to it to get my what I want to do. So let me kind of show you how this would work in this problem. If this is my percentile, I'm going to get my actual P80 by taking the mean and adding it to the standard deviation times the z-score, which is 0.84. So I got this from finding the 80th percentile in the table, the z-score table. So I'm going to do that in my calculator now. I think order of operations is going to work out because it's going to do the multiplication and then add it. So I get 41.552. Let's round it to 2 decimals. 41.55. I picked 2 decimals because that's in 2 decimals. In other words, my P80 is equal to 41.55, which means that 80% of the people have chest sizes less than that, 20% have chest sizes more than that. Okay, so this is the method that you're going to use to find percentiles using the table. Is find the percentile with standard normal and then use this formula to convert it to whatever the distribution is. So you need to know the mean and the standard deviation, which you're going to know in order to do it. All right, let me do one more and then wrap this video up. So exact same kind of question. We're going to find the 34th percentile. So I'm going to start by, well, let me show you what it looks like in the graph first. So I'm going to start by putting it on here. So this is 34. And I'm saying that 34%, this is P34, 34% are less than this line, and the other 66% are greater than this line right here. So I'm going to go to my table first and find where 34% is. So in my standard normal table, I'm looking for 0.34, and you may have found it already. I haven't. 0.3446 is right there. This is kind of going backwards. I see. 0.3409. And that's 0.3372. So this is closer. This is closer. So we'll do 0.3409. We'll do negative 0.41. Yeah. Negative 0.41 is going to be our 34th percentile. for standard normal. Let me change these colors up. So now I've got to convert this number to a normal with the mean of 39.83 and the standard deviation of 2.05. So I'll use that formula I showed you on the last slide. X is equal to 39.83 plus 2.05 times negative 0.41. Now I want to put in a calculator with those parentheses so that negative doesn't mess with me. So 39.83 plus 2.05 times negative 0.41. Make sure you use this negative sign, not the minus sign. It gets mad at you when you use the minus sign as a negative. And my answer is going to be 38.99. 38.99 inches. And maybe in practice you'd want to round that up to 39 even. It's very, very close. But this is my 34th percentile. So I'm saying that 34% of the people are less than this. 66% of the people are more than this. 38.99 inches. So that's how you do these kinds of normal distribution problems. When you don't have a mean 0 and standard deviation 1, you use the z-score formula. Let me show you that last slide again. You use the z-score formula to go from some normal to normal 0, 1. You use this green formula to go from normal 0, 1 to whatever normal distribution you need with the mean and the standard deviation. And so what I'm saying is these formulas are really powerful because they allow you to use the table to find any probabilities. Now your TI calculator can also find probabilities, frankly, much easier. I want to save you that tutorial for a different video.